Hello everybody. Today we have a really cool problem that had come in the ISI exam, Indian Statistical Institute, and it involves a little bit about repeated roots of a biquadratic. And it's a really cool problem. We're going to look at a really interesting way to solve it. There is like a brute force way involving calculus, which is really lengthy. We're just going to use like a simple substitution strategy and that will solve the problem. So let's begin. And this is the problem number 2 from the ISI Entrance test in 2013. And in this video, we have a problem involving roots of a biquadratic. We are going to learn about the concept of repeated roots and how to find repeated roots of not only a quadratic polynomial, but also of a polynomial of n degree. I'm going to give a little bit of insight into that. And we also have some book suggestions of ISI and CMI, and we have a similar problem for you to try it at home.
This video is sponsored by Chinta.com. Since 2010, Chinta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students. Chinta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Chinta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Chinta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit Chinta.com.
Cool, so let's begin. The question says, let A be a fixed real number, and then consider the equation x plus 2 whole square plus x plus 7 whole square plus a is equal to 0. And x belongs to the set of reals. For what values of A will the equation have exactly one double root? So whenever you hear of a double root, you kind of like automatically think that the discriminant needs to be 0, right? So for example, if we have a polynomial p of x is equal to ax squared plus bx plus c, and it is given that this is a double root, so we can directly say that the discriminant is 0. So b square minus 4ac is equal to 0. In other words, b square is equal to 4ac. This is the condition for a double root of a quadratic polynomial. Now, in general, if you need to find a double root of a polynomial of n degree, again, you have to put discriminant equal to 0. But then the question arises of how can you find the discriminant of a polynomial that's not a quadratic? How do you find the discriminant of a polynomial of n degree? Right? Well, we have the discriminant of a polynomial f of x of degree n, right, can be like written in terms of the determinant of the Sylvester matrix of f of x and f prime of x. So that's just a constant in calculus, but we really don't need to go that way, right? We don't need to go into that form of Sylvester matrices and all. What we're going to do is we're going to use a simple trick. You can call it a trick, you can call it a substitution strategy, whatever. But we're going to see an elegant solution of this. We're going to see how this can be solved easily, right? Cool. So here we have like a biquadratic function, x plus 2 whole square times x plus 7 whole square. A quadratic times a quadratic is a biquadratic. Plus a is equal to 0. And again, we need to find out the values of a that will make this polynomial have a double root, right? So now you might have seen this formula in elementary algebra that a square minus b square is nothing but a plus b times a minus b. And whenever in general we have quadratics and you want to find the roots of it, factoring is obviously one of the easier methods to go about. So if this a was of the form minus t square, then we can write this entire thing in the form of a square minus b square and then factor that out, right? So what I'm going to do is I'm going to substitute a is equal to minus t square with t greater than 0. Alright. So here we will have x plus 2 whole squared times x plus 7 whole squared minus t square is equal to 0. And let me just change my color. Let's use orange, right? Alright, so now we can easily factor this out. So this turns out to be x plus 2 x plus 7 minus t times x plus 2 x plus 7 plus t. And this entire quantity is equal to 0. Now it's pretty clear that x plus 2 times x plus 7 minus t and x plus 2 times x plus 7 plus t, both of them cannot have the same root, right? So they cannot have the same root at the same time. It's kind of the crux of it. So they cannot have the same root, right? So that naturally means that one of them has to have a double root, right? So if I define the polynomials that say q of x is equal to x plus 2 times x plus 7 minus t and r of x is equal to x plus 2 times x plus 7 plus t, one of them has to have a double root. Okay, one of them has to have a double root. So we're going to assume two cases. Obviously, case one is x plus 2 times x plus 7 minus t has a double root, right? And double root means discriminant is equal to 0. And here we have a quadratic. So the discriminant of this comes out to be 81 minus 4 times 14 minus t. You can just open this out and check this for yourself. And this comes out to be 25 plus 40. And if this discriminant is 0, that means if it has to have a double root, the discriminant obviously has to be 0. So 25 plus 40 is equal to 0, or in other words, t is equal to minus 25 by 4. But we had assumed over here, or we had given the condition that t is greater than 0. Right? That was kind of a starting point. This case is automatically rejected. And we move on to case 2. Case 2 is that x plus 2 times x plus 7 plus t has a repeated root, right? And now the discriminant over here is 81 minus 4 times 14 plus t. So the discriminant here, d2, I'm using as d2, comes out to be 25 minus 40. And when d2 is equal to 0, we get t is equal to 25 by 4, which is a valid value of t, right? And a was nothing but negative t squared, so which implies a is nothing but negative times 25 by 4 whole squared. So therefore a is equal to minus 625 by 16, and that completes the solution. So as you can see, we really didn't have to use calculus over here. We could have done it that way as well. Some people use the concept of Sylvester matrices, but this is, in my opinion, a much more elegant solution to the problem and much more simpler solution, right? We can deal with biquadratics a lot more easier if we can just factor them out. And now after this, we have some book suggestions for ISI CMI. Challenges and Thrills of Pre-College Mathematics. This is a very famous book. Mathematical Circles, a Russian Experience. Excursion Mathematics, a test of mathematics at 10 plus 2 level. Elementary Number Theory by David Burton, and Principles and Techniques in Combinatorics. So all of these books are really good for ISI and CMI, both of these entrance exams. And yeah, at the very end, I have a similar problem for you to try out. And we have an equation, ax cubed minus x squared minus x plus 2. And it is given to us that this equation has a double root. And if it has a double root, we need to find out the value of a. This is a slightly interesting problem, something similar, something along the same lines that we discussed above. Maybe get the idea of determinants. You'll have to use the idea of determinants maybe a little bit more over here. But yeah, as usual, if you make any progress on this or if you're able to solve it, please let me know down in the comments below. Until then, I'll see you later in the next video. Bye-bye.